Today we are learning about quadratic functions. The following vocabulary is very essential to understanding your following lessons, so feel free to pause and screenshot and or write the vocabulary words. Our first lesson is solving quadratic equations by completing the square. Now it's important to have the leading coefficient of 1, which is what we have in front of x squared. Now you want to exclude x squared plus 8x away from the constant and y. So you can move those aside. So x squared plus 8. Now you want to put positive 12 equals 0 because you want 0 to always be your y in a quadratic equation. So, Okay, so you want to divide your coefficient of x over 2, which in our case is 4. Now remember that number, because you're going to put it in your equation later on. So you square that, which in our case is 16. So you put 4 in your equation, so you put x plus 4. Now square that. And then you equal that to your original constant, which is 12, and add that to your new number, which is 16. So you simplify it down to x plus 4 squared equals 28. So now you want to get rid of that squared. So you square root both sides, because what you do on one side, you have to do the other. So that simplifies down to x plus 4 equals 7, plus or minus 7. Now you want to subtract 4 to both sides, and you have to subtract 4 to both positive and negative 7. So positive 7 minus 4, which gives you x equals a positive 3. Now if you subtract negative 7 minus 4, gives you a negative 11. So those are your solutions. Now we are solving the quadratic equation using the quadratic formula. Now this is really easy. All you have to do is plug in your a, b, and c to the formula on the right hand side. So 2 is your a, 8 is your b, and 16 is c. You can remember c as in your constant. So you just plug in x equals negative 8 plus or minus the square root of 8 squared minus 4 times 2 times negative 16 over 2 times your a, which is 2. And it's always easy to put this part into your calculator first so you can simplify and you don't get any weird errors. So you can put that into your calculator using either the plus or minus. So using the plus, you get a positive 2 square root of 3 minus 2. Or if you put it in the minus or negative, you get a negative 2 square root of 3 minus 2. And that is your solution. So now we are solving the quadratic equation by factoring. This is also really easy if you do it correctly. So now I have to find what multiplies to 6, or the constant, but adds to the coefficient of x, which is 5. So what two numbers add to 6? What I got was 2 times 3. Now lucky in our situation, 2 plus 3 also equals our coefficient of 5. So we just have to put those two numbers in the equation. So you put x plus 2 times x plus 3. So that automatically gives your solution, which is x equals a negative 2 and a negative 3. And it's always negative when it's positive within the equation, so that should be easy to remember. Okay, now we are solving the quadratic equations by using square roots. Now all you have to do is get your constant away from your x variables. So you are adding 4 to both sides in our case, which ends up equaling x squared equals 4. Now after that, you have to get rid of the square. So you have to square root both sides, because what you want to do to one side, you have to do the other. So that ends up equaling x equals a positive or minus 2. And that would be your solution. We are solving a system of quadratic and linear equations by graphing. So to solve the system by graphing, all you basically do is input each of the individual equations into your handy calculator using your table key, and which will give you the points, and basically you go from there and graph it. So I don't know if you can read at the bottom, but that's supposed to say there's no real solutions is what you would find out when you graph it. So now the next part is just by checking and working out. So you can pause this page and either screenshot it or write it down or print out the guided notes, which is also provided. And this basically just shows you how to solve this equation of system equations algebraically, like step by step, and there's also a little hint on the side too, like add 2 to both sides, subtract 2x from both sides, and factor. And now we are going to learn about how to check your answers. So here, once you get your answers, you just plug in your x and your y into the equation y equals x squared minus x minus 6. So you put that answer, and once you get that answer, and you get 6 equals 6, that means that you get it right, or negative 4 equals negative 4, which is the next equation, that means you got it right. So if your x equals your x when you check it, or your y equals your y when you check it, it's all good. Graph the quadratic equation and find the vertex x and y intercept maximums and minimums, directrix and focus. Now to do that, you have to plug this equation into your calculator using your table key. Now once you get it, you get the following points right here, and then you plug in those points and put onto your graph, which makes it look like that. So that shows it opens up, or in other words, it has a minimum. Now the next step is to find the vertex. Now to find the vertex, use the formula to find x. You use negative b over 2a, and for y you just plug in what you get for x. So let's see, the coefficient of x squared is a, the coefficient x is b, and the constant is c. So you plug those things in. So you do positive 2, because this is because the 2 in the equation is negative, and a negative plus a negative is a positive, and 2 times 1, and that equals 1. So you plug in 1 into your equation right here, and you get 3 for y. So your vertex is 1, 3. Now, let's find the directrix and focus. Now, the distance between the directrix and vertex is the same as the distance between the focus and the vertex. Now, to find that distance, you have to multiply a times p equals 1/4. Now, your a is the coefficient of x squared, which is 1, times p equals 1/4. So your distance between directrix and focus from the vertex is 1/4. Now you subtract 1/4 from 3, and you get 11/4. Y equals 11/4. And you add 1/4 to your y-intercept to get your focus, which is 1, 13/4. Now we have to find the axis of symmetry. Now the axis of symmetry is the line that goes straight through the middle. In our case, it's right where the vertex is, which is 1, 3. So your AOS, or your axis of symmetry, is simply x equals 1. And that is it for standard 3.
Okay, Jackson throws a ball in the air at the same time that Chase lets his helium balloon loose. Oh no. The ball is moving at a rate of 20 inches per second and the balloon is moving at a rate of 5 inches per second. When will the ball and balloon reach the same height? Well, to figure this out, first we have to write the equations for both Chase and Jackson. Okay. So since x equals seconds and f of x is height, the equation for Chase is f of x equals 5x. All right. And the equation for Jackson, since as well f of x is height in inches and x is seconds, and negative 16x squared represents the force of gravity, his equation is f of x equals negative 16x squared plus 20x. All right. So, since both equations are equal to f of x, to solve this problem, you first set both equations equal to each other. So 5x equals negative 16x squared plus 20x. Now, you want to set the function equal to 0, so you subtract 5x from both sides. And when you do this, you get negative 16x squared plus 20x minus 5x. Now, to simplify this down, you would just do 20x minus 5x, and you would get 0 equals negative 16x squared plus 15x. Now, next you would factor out the negative x, and this leaves you with 0 equals negative x times 16x minus 15. Now, the next step is to set negative x equal to 0, which would just give you x equals 0. And this represents the initial point when both the balloon and the ball are thrown into the air. Now, to find when both the ball and balloon reach the same height, you would take your equation 16x minus 15 equals 0, and you would add 15 to both sides, which would give you 16x equals 15. Now, your next step is to divide both sides by 16 to get x by itself. Now, when you do this, you are left with x equals 0.9375. And so at 0.9375 seconds, the balloon and the ball will be at the same height. The next step of this problem is to graph the equations. So when you plug the equation into your calculator, for Chase, you should get 1, 5, 1.5, 7.5, and 2, 10. And then when you draw your line, it should look something like this. Okay. And now we have to graph the equation for Jackson. So when you plug that into your calculator, you get 0, 0, 0.56, and 1, 4. When you draw it, it should look like this, roughly. And you can see, according to the math we did, they are at the same height at about 0.9375 seconds.
Calculating and interpreting the average rate of change. If an object is dropped from a building, then the distance it has fallen after t seconds is given by the function d of t equals 16t squared. Find its average speed, or the average rate of change, 1 second and 5 seconds. And highlighted in blue is a formula you will use, or the average rate of change formula. So you plug in 5 and 1 as in your seconds, or 5 as in B and 1 as in A. And then you plug in 16 as in D as in your distance, and you square it. And then you end up getting 400 minus 16 over 4, and that ends up equaling 96 feet per second. So we're now using the table to find the average rate of change over the following intervals. So you use the equation f of b minus f of a over b and a. Now you want to input your intervals x equals 0 and x equals 2. And then you go from there, and then you get negative 3 minus 5 over 2 minus 0. And that simplifies down to negative 8 over 2, which goes to 4. Estimate the rate of change from the graph. Consider a parabola y equals x squared. Now remember, the average rate of change also equals the slope. Now the equation for slope is change in y over change in x, or y2 minus y1 over x2 minus x1. Now the points being used, 0, 0, and 1, 1. The average rate of change for that would be 1, because you get 1 over 1. And then for the points 1, 1, and 2, 4, the average rate of change would be 3, because you get 3 over 1. Now the average rate of change for 2, 4, and 3, 9 is 5, because you get 5 over 1. As you can see on the graph, it is demonstrated. Thank you for watching, and please feel free to rewind and screenshot any notes you want later.